Okay, so to start today's lesson, we are going to have you fill in the blank on the knowledge you should have of the basic background of normal distribution and a bit of a recap of binomial. So please go ahead and pause the video now and see if you can fill in the blanks. You should have done that by now. Binomial recap. Y is distributed. B means it's a binomial distribution, with n being the number of trials that you do, and p is the probability of success. And the data for binomial is discrete. The new topic we've been learning is normal distribution, and it is represented by n for the distributed normal distribution, with a mean, median, and mode. Mean, median, and mode of mu, which is our first parameter. And the second parameter is always sigma squared, and sigma is your standard deviation. And for a normal distribution, the data is continuous. Now you should have a few of the standard deviations from the mean memorized, such as 68% lies within one standard deviation of either side of the mean, whereas 95% approximately, that's what we can use, lies within two standard deviations. And the final one is 98.7% lies within mu plus or minus 3 standard deviations of the mean. We can also assume that all data for our purposes lies within 5 standard deviations of the mean. So if we're ever needing to input a lower or upper bound and we aren't given it, always go more or less than 5 standard deviations from the mean, which is why I always do like negative 10,000 or positive 100,000. There's a good chance they're good numbers to use. Now, a normal distribution has a bell-shaped curve, and we'll be recapping a little bit more about the curve and how it works. But it's really important that the area represents probability. And therefore, as in all things, when we're dealing with probability, the total of it needs to add to 1. Now if we're in percentage, that would be 100%. So that's the beginning of your recap, and we will be recapping the use of the bell curve next before we move on.